So good morning to everyone. So good morning. Okay. So before starting with the today's concept, so can anyone tell me what we have discussed in the last class? What we had discussed? Hmm? That is related to chemical properties, right? So in that chemical properties, what we had discussed? Forgotten? Okay. So we have done with the electrophilic substitution reaction, right? So we have discussed electrophilic substitution reaction with respect to phenols. So with respect to phenols, so that's where we have nitration. Now when it comes to nitration, what is the speciality of the phenols? How they differ from other molecules or alcohols? Means other molecules, not alcohol. Other molecules, how they differ? What is the speciality? Here, instead of using nitric acid and sulfuric acid in combination, we will use only dilute HNO3. Right? So we are going to use dilute HNO3. That's where they differ with respect to nitration. Right? So in other cases it used to be nitric acid and sulfuric acid. Here it is only dilute HNO3. So mono substituted product. We used to get mono substituted product, that is ortho and para position. Nitrate group will be at ortho and para position. Nitro group will be there. So that's where we have the mono substituted product. Now what is the speciality of those molecules? So those molecules, one of them will be having hydrogen bond. Will be having hydrogen bond within the molecule. That is intramolecular hydrogen bond. But another molecule will have the intermolecular hydrogen bond. Right? So here it is intra. Right? But when it comes to paranitrophenol, it will be intermolecular hydrogen bond. So due to that, they differ in their physical properties. And due to that, we can separate them from each other. Right? So that's why. Oh. Fine? So that's where we have the picric acid. So what do you mean by picric acid? Picric acid is nothing but 2, 3, 4, 5, 6. So that means 2, 4, 6. Trinitrophenol. Trinitrophenol. That is nothing but picric acid, which should be a strong acid. Picric acid should be a strong acid. That's where we have the picric acid. Right? So how picric acid will be synthesized? Picric acid. Okay. Fine. So all of you can see me, right? So that's where we have the picric acid. 2, 4, 6. Trinitrophenol. Okay. Now when it comes to preparation, normally how they are going to prepare picric acid? Concentrated HNO3, yes, it will give. But normally first they will go with sulfonation. Then they will go with the nitration, right? So phenol will be there. First they will go with the sulfonation. That means by treating with the H2SO4. Then they are going with the nitration at the end, where they are going to treat with the nitric acid. So why picric acid will be prepared like this from phenol? So that is because if I am using concentrated HNO3 as it is directly, now what will happen? So reaction can be uncontrollable. Product will be there, no doubt. But along with that, there will be formation of oxides of nitrogen. So to avoid that, we will go with the first sulfonation, then we will go with the nitration. Fine. So that's where we have the picric acid. Same way, when I am talking about phenol, if I go with halogenation, so what will be the product when bromine in the presence of carbon disulfide or chloroform is treated with phenol? Anyone? What will be the product when bromine, phenol is treated with bromine in presence of carbon disulfide and chloroform, any organic solvent? So the product will be mono-substituted product. It will be mono-substituted product. Right? Either it can be ortho or it can be para. So that's where we have the mono-substituted product. All of you have understood? So that's where we have the bromine in organic solvent. Same phenol, if I treat with bromine, that is bromine water. So what will be the product now? When phenol is treated with bromine water, what will be the product? It will be 2,4,6 tribromo phenol. It will be 2,4,6 tribromo phenol. That's where we have the reaction, halogenation, right? So first case, bromine in organic solvent, non-polar solvent. In second case, it will be bromine water. Any doubts? Okay, so that's where we have the halogenation. Then we have discussed about one of the important reaction, that is nothing but coal-base reaction. Then we have discussed about coal-base reaction. Now, what do you mean by coal-base reaction? What will happen here? Phenol will be getting converted into salicylic acid. Here, phenol will be getting converted into salicylic acid. Right? So, first it has to be treated with sodium hydroxide. Right? I will not write the reaction in detail. First with sodium hydroxide, then with carbon dioxide, and then we have to provide the acidic condition. So that's where we are going to get the salicylic acid. That's where we have the coal-base reaction. Then next one is Reamer-Tiemann reaction. Right? Reamer-Tiemann reaction, another important reaction. So in this case, what will happen? Phenol will be converted into salicylaldehyde. Right? Phenol will be converted into salicylaldehyde. So here phenol is getting converted into salicylic acid. But here phenol will get converted into salicylaldehyde. Okay. I will use black ink only. Sukrut, fine. I will use black ink. So that's where phenol will get converted into salicylaldehyde. Okay. So now, which are the reagents they will use? They will be using sodium hydroxide once again. Then they will use anyone? That is chloroform. They will use chloroform. So that's where we will be having salicylaldehyde. Okay. So yes, Bhavani, I have changed the marker. Okay. So I was using blue ink. Now I am coming back to black ink. So that's where we have the Reamer-Tiemann reaction and coal-base reaction. Very important. Now, next another important reaction is when we are talking about phenol which is treated with zinc dust. What will be the product? When phenol is treated with zinc dust, what will be the product will be benzene, right? So product will be benzene and zinc oxide. Another important reaction what we have discussed. Then when phenol is treated with sodium dichromate, so when it is treated with sodium dichromate, what will be the product? So product will be quinone, benzoquinone, right? So it is a oxidation where phenols will be oxidized to ketones. So that's where we are going to have the benzoquinone. Okay, so that's where we are having the benzoquinone. Now you should tell me what will happen phenol if it is not stored properly. Yes, Manvit, it will be benzoquinone. So what will happen if phenols are not stored properly? I have told. After this reaction I have told. So phenols if they are not stored properly, when they are exposed to the atmosphere, slowly they will get oxidized. It will get converted into dark colored solvent, right? So that is because of the formation of quinone derivatives, right? So that's where we have the reactions. At the end we have discussed about wood spirit. What do you mean by wood spirit? That is nothing but methanol, right? So which will be prepared from water gas. So that is carbon dioxide and hydrogen, right? So by using these two molecules we are going to have the methanol, commercial preparation of methanol. And methanol is toxic, no doubt. Methanol is a toxic molecule. Fine. Now we are coming to the important molecule, that is ethanol. This is today's concept. We have not discussed this one in the last class. So it is ethanol. Now when I am talking about ethanol, what is the molecular formula? C2H5OH. Right? So methanol, now this is ethanol. Now whenever we are talking about ethanol, all of you know, it is having plenty of application. Right? So one application is Odalo. So along with that it is having industrial application also. It is a very good organic solvent which can be miscible with water also. So that's where ethanol is having plenty of application. Now when it comes to preparation, if you go to Nanjangud, we have Bacardi plant, right? So where there will be a fermentation process. Biology students will be knowing. So we have a process called as fermentation. That means in this case, in the absence of oxygen, in the case of fermentation, there will be absence of oxygen. There should not be any oxygen. So in the absence of oxygen, they will make glucose to get catabolized or degrade. They will make glucose to get degraded. Biologically, if you want to tell, catabolized. So which will get converted into ethanol. Right? See, it's a simple process. If all of you are, as the humans, if you are doing some exercise, now what will happen? Our muscles will utilize the glucose to get the energy. Right? Now, all of us, we are going to respire. Right? Respiration process is happening. We are inhaling the oxygen. So in the presence of oxygen, it will get converted into carbon dioxide and water. And during that process, there will be release of energy, ATP, which will be utilized by our tissues or our muscles, by our system, our brain will utilize. So that's where we have the glucose. It is called as aerobic condition because aerobic stands for presence of oxygen. Now, when you are doing a vigorous exercise, either running, right? So vigorous exercise when you are doing, oxygen will have the limitation. Its concentration will not be enough for your system to get utilize those oxygen. It will be completely exhausted oxygen. Now partly your muscles will go for anaerobic condition where there will be formation of lactic acid. So due to the formation of lactic acid we will have the pain. when you are lifting the dumbbells after 20 rounds, at the end your hands will tell, muscles will tell, no, 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 now I can't. You will put down the dumbbells, right? So that is because of formation of lactic acid, right? But if you take some of the yeast and bacteria, if you take some of the yeast and bacteria with the same condition, that is anaerobic condition, under anaerobic condition, they will convert glucose to ethanol. Very bad, right? Even you would have done means bar shop would have been closed. If even our body would have prepared ethanol, bar shop would have been closed. Now I am simply making fun. So glucose in case of humans, it will get converted into lactic acid under anaerobic condition. But same glucose under anaerobic condition in yeast and bacteria, some of the bacteria, they will get converted into ethanol. Fine? So that's where it has been utilized for the industrial purpose. This particular thing they have utilized for the industrial purpose, where they will make these organisms to grow, bacteria or yeast. They will make these organisms to grow under anaerobic condition. So due to that, glucose will be getting converted into ethanol. Glucose will be getting converted into ethanol, right? Or another method here is, all of you know what you mean by sucrose, right? So all of you know what you mean by sucrose. It is a disaccharide, right? Where we will be having glucose and fructose. So that is C12H22O11, right? So they will make this one to get hydrolyzed. That is by the help of invertase enzyme. By the help of invertase enzyme, they will make this molecule to get hydrolyzed. I am telling hydrolysis. So that's where water I have shown. So they will undergo for hydrolysis to form C6H12O6, that is glucose, plus C6H12O6, that is fructose. Right? Since water molecule is present, instead of C12H22O11, since water molecule will be added, it will become C6H12O6 of two molecules. One is glucose and one is fructose. Right? That's where we have the invertase. So what is invertase? It is an enzyme which will act on the sucrose, which can also be called as sucrase. Right? Now, whatever monosaccharides we have got, especially glucose, even fructose can be converted into glucose. So whatever monosaccharides are there, now it will be treated by the group of enzymes called as zymase, which was isolated from the yeast. Zymase is a group of enzyme which was isolated from the yeast. So by utilization of zymase, it will get converted into ethanol. They will get converted into ethanol. But very important point here is, they have to maintain anaerobic condition, no doubt. They have to maintain anaerobic condition. Otherwise, it's not possible. We have to maintain the anaerobic condition. And along with that, there will be formation of carbon dioxide. There will be formation of carbon dioxide. That's where we have the reaction. All of you have understood? Fine? Any doubt? So, balancing may not be required, but anyway, we will do it. 24 hydrogen is there. So here 6. So 4. Right? The rest of them will make it as carbon dioxide, 4CO. Since I have taken 2 molecules, therefore 4 molecules of ethanol and 4 molecules of carbon dioxide. Right? So in organic chemistry, as I told, balancing fine. It's a simple equation. Therefore I am balancing it. It's fine. So that's where we have anaerobic condition and zymase. Now we should be very careful. That's why this process is called as fermentation. So this process is called as fermentation. Okay. So alcohol, ethanol will be commercially prepared by using fermentation process. Right? So now, what will happen if oxygen is there? Right? Someone has forgotten. So to close the instrument properly has forgotten. Some portion has been opened. So atmosphere oxygen is entering. Now what will happen? It will spoil the taste of the alcohol. Because when there is a presence of oxygen, there is a chance that partially there will be formation of acetic acid. Instead of ethanol, some of the acetic acid will also get formed. Right? So we have to avoid the formation of this acetic acid, otherwise it will spoil the taste. Right? So therefore anaerobic condition strictly we have to maintain. All of you have understood? Otherwise there will be a contamination of acetic acid if there is a oxygen. Fine? So that's where we have the commercial preparation of alcohol. So commercially how alcohol will be prepared? From the sugar, that is sucrose, which will be treated with invertase. Then there will be formation of glucose and fructose, and later under anaerobic condition they will be getting converted into ethanol and carbon dioxide. And the process is called as fermentation process. Fine? All of you have understood? So this is where we have the commercial preparation of alcohol. So for alcohol synthesis or preparation, what is very much required? Very much requirement here is absence of oxygen. Oxygen should not be there. We have to go with anaerobic fermentation process. Fine? Any doubts? Okay, fine. Now when it comes to laboratory, whatever alcohol is there in the laboratory, in your lab, you might be having in chemistry lab, or even biology lab also you might be having 1 or 2 bottles of alcohol. Now that alcohol is non-consumable. We cannot consume that alcohol. Otherwise what would have happened? Right? Lockdown. No bar shop is open. So what people would have done? Open the lab, take the bottles. Right? So they can't do that one. That is because those alcohols has been denatured. Those alcohol has been denatured. Denatured means spoiled. Oh sir, then it is not alcohol. The alcohol is there, but that alcohol is added with pyridine. It is added with pyridine to have the bad odor. It will be added with pyridine. Then to some extent small amount of copper sulfate they will add to give the blue color, so that it can be discriminated from other organic solvent. So therefore it is called as denaturation of ethanol. So what do you mean by denaturation of ethanol? Denaturation of ethanol is nothing but adding the copper sulfate and pyridine to the alcohol. Why we have to add these things? To avoid or to make alcohol non-consumable. Right? So it should be used only for reactions or chemical process. So it cannot be used for consuming purpose. So that's where they are going for denaturation of alcohol. All of you have understood? So which are those 2 molecules which is going to be added? That is pyridine, a heterocyclic compound, and copper sulfate. Right? So copper sulfate will be added in small amount. In some cases they will not add the copper sulfate also, if sometimes it may interfere with your chemical reaction, but they will add pyridine. Okay? So whether I am clear? Any doubt? This is with respect to ethanol. So by this I have done with the alcohols and phenols. But any doubts until now? Okay? So in that case we have to move to next one, ethers. We have to move to ethers. Fine? Now when I am talking about ether, when it comes to first step, it is preparation, because already we have done with types of ethers. Then we have done with IUPAC nomenclature also with respect to the ethers. So which are those types of ethers? That is simple and complex ethers. Symmetric, unsymmetric or asymmetric. That's where we have the different classification of ethers. Okay. So in that case, now can you tell me what will happen if I have taken ethanol, okay, and I will heat it up to 450 Kelvin approximately. I will heat it up to 450 Kelvin in the presence of sulfuric acid, no doubt. What will happen? Already we have discussed this reaction. So I am talking about preparation of ethers. What will happen? We have ethanol. We are heating it up to 450 Kelvin in the presence of sulfuric acid, concentrated sulfuric acid. What will be the product?
O1SO3H.
It will be 450 or 440. This reaction we have already discussed. So normally, not normally, it will give ethene. It will go for dehydration. Right? It will undergo for dehydration reaction. There will be formation of ethene. If you recollect, 440 to 450 Kelvin we have to heat. But same molecule, that is ethanol, same molecule of ethanol, we have to take another ethanol also, CH2OH. In the presence of sulfuric acid, temperature can be around 410 Kelvin or 413, 400 to 415, 15. So that particular temperature, now it will get converted into ether. Now it will get converted into ether. Where there will be liberation of water? Yes, there will be a liberation of water, no doubt. So what is happening? Ethanol molecule, when you heat it bit high temperature, around 450 Kelvin, now there will be formation of ethene because it will undergo for dehydration. Same alcohol molecules, bit low temperature, in the presence of sulfuric acid, it will undergo for dehydration once again. But there will be formation of ether. This is nothing but diethyl ether. This is nothing but diethyl ether. Idana ನೆನಪಿಟ್ಕೋಬೇಕು. Fine. So they may ask the question, name the product formed when ethanol is heated at around 400 Kelvin in the presence of sulfuric acid. Many students they will write ethene. It is wrong. It will be ether, diethyl ether which will be formed. Ethene will be formed when you are talking about temperature above 440 Kelvin. Then only ethene can be formed. Below 400 or below 420 Kelvin, ethene will not be formed, it will be ethers which will be formed. All of you have understood? So you have to remember this one because whatever preparation I am going to tell, this is important. Whatever preparation I have told, this is important because there is a mechanism. See, 3 mechanisms that are present in alcohol topics itself. So there is a mechanism for this reaction. Whether I am clear? All of you have understood? Fine. So ethanol, when you go for a bit higher temperature, it will undergo for dehydration to form ethene. Ethanol, bit low temperature, it will undergo for dehydration to form the ether. Fine. So that's where we have the reaction. First thing, whenever we are talking about preparation, so preparation of ethers from alcohol. Whatever we have discussed is preparation of ethers from alcohol. First we have to write the overall reaction. So 2 molecules of ethanol. So 2 molecules of ethanol in the presence of sulfuric acid, and temperature can be somewhere around 410 Kelvin. So there will be formation of diethyl ether. There will be formation of diethyl ether plus water. So plus water, that is the reaction, overall equation. Okay. Now it will show SN2 type of reaction. It will show SN2 type of reaction. That means nucleophilic substitution bimolecular reaction. It will show a nucleophilic substitution of bimolecular type of reaction, where rate of the reaction will be decided by 2 molecules. Rate of the reaction will be decided by 2 reactants. So that's where it will follow SN2 reaction mechanism. Okay. Now step 1. Once again, it is a 3-step process. So step 1, that is protonation. Sulfuric acid we are using, right? So that's where protonation of alcohol, that is ethanol. Step 1 will be protonation of alcohol or ethanol. Why protonation? Because we are going with acidic condition. Sulfuric acid we are adding, right? So that's where we have C2H5OH, right? Lone pairs of electrons will be there. It will be attacking the H plus. It will be attacking the H plus to form the product C2H5, where oxygen will have the positive charge. Where the oxygen will have the positive charge. Oxonium intermediate will be formed. Right? So that's where we have the protonation of alcohol. Or you can tell that it is a nucleophilic attack of ethanol on the H plus. Anything is fine. Or you can mention that first step as nucleophilic attack of ethanol on H plus or proton. Nucleophilic attack of ethanol on H plus or proton. One and all same. Protonation of alcohol or nucleophilic attack of ethanol on H plus. Fine. And this will follow nucleophilic substitution reaction bimolecular type, not unimolecular. It's a SN2 reaction. Okay, that's where we have the overall equation, where 2 reactants are involved in the reaction. Whether I am clear? So this is step 1. Now, step 2. Can any one of you tell me what can be step 2? Can any one of you tell me what can be step 2? Step 2 will be, since 2 molecules of ethanol is there, right? So step 2 will be nucleophilic attack of ethanol. Nucleophilic attack of ethanol on protonated alcohol or ethanol, on protonated ethanol or alcohol. Nucleophilic attack of ethanol on protonated ethanol, because 2 molecules of ethanol, they are involved in the reaction. So that's where I have got C2H5OH, lone pairs of electrons are there, and here oxygen is very upset because it's going with positive charge. It's going with positive charge, oxonium, right? So therefore, this oxygen will tell to this oxygen. So don't worry, I am here, right? Whether I am clear? So that's where, oh sorry, not with this oxygen. to this neighboring carbon because it is torturing the carbon, right? Okay, instead of 1 minute, I will write it as CH3CH2. Instead of C2H5, CH3CH2OH plus CH3CH2. Okay? So instead of C2H5, I have written like this. Now this oxygen will be torturing this carbon, right? So it will be telling this carbon, give me the electron. So this carbon will be taking the confidence of this alcohol, OH group, O. So that's where there will be shifting of the linkage. So due to that, this will be liberated as water. Right? This will be liberated as water. So what is left over? Left over is CH3, CH2OH, CH2, CH3. Right? Whether I have written perfectly? Any mistakes are there? So what is that? I have to show the positive charge on the oxygen. Otherwise, I am going to lose the marks. I have to show the positive charge. So what is happening? We had protonated alcohol where this oxygen is becoming an oxonium ion. So therefore, it will be torturing the neighboring carbon to donate the electron. So therefore, this oxygen of another molecule of alcohol, it will tell to this carbon that leave that oxygen. We will make a linkage. So that's where we have the linkage. Right? All of you have understood? So where alcohol and there will be formation of linkage between carbocation of another dehydrated alcohol. So that's where we have the intermediate. All of you have understood? Now the last step, that is step 3. Last step is deprotonation because H2SO4 should not be consumed. It is acting as a catalyst. So whatever H plus has been utilized, it has to be given back. So therefore last step will be deprotonation. Last step will be deprotonation. Right? So there what will happen? Whatever intermediate is there, CH3, CH2OH, positive, CH2, CH3, whatever is there, it will take the electron from the hydrogen. Oxygen will take the electron from the hydrogen. There will be formation of H plus and ether, diethyl ether. Whether all of you can see the board, it is visible? I think it is visible. Okay. Now it's very clear, right? So that's where we have the last step. Listen to me carefully. So I am talking about the mechanism for preparation of ethers from alcohol. So which alcohol we have taken as the example? Ethanol as the example. Now ethanol in the presence of sulfuric acid at bit low temperature, that is somewhere around 400 to 415 Kelvin, 415. So there will be formation of diethyl ether due to the dehydration. So what is the mechanism? It will follow SN2 reaction mechanism where in step 1 there will be protonation of alcohol will take place. So this can be protonation of alcohol or nucleophilic attack of ethanol on H plus, one and all same. So therefore there is a nucleophilic attack of ethanol on H plus. So that's where we have the oxonium intermediate where oxygen is carrying positive charge. Now step 2 where nucleophilic attack of ethanol on protonated ethanol will take place. Because when we are talking about reaction solution, we are not taking one molecule of ethanol, we are taking n number of molecules of ethanol. Therefore, some of them will be protonated and some of them which are in ethanol form. Now that ethanol is going to have the nucleophilic attack on the carbon because This oxygen wants to take back the electron, therefore this carbon will be attacked by the neighboring ethanol, right? So that's where there will be liberation of water. That means dehydration has taken place. Liberation of water, and that's where there will be an intermediate where once again oxygen is having positive charge, oxonium form, right? Now step 3, deprotonation. Step 3 is deprotonation, because whatever proton has been utilized, it has to be given back. Sulfuric acid will not be utilized in the reaction. It will catalyze the reaction. So therefore, whatever oxonium intermediate is there, it will release the H plus and there will be formation of diethyl ether. There will be formation of diethyl ether. That's where from alcohol we can prepare the symmetric ethers. Whatever I have taken, it is a symmetric ether. Now I will make it very clear. This method cannot be used. This method cannot be used for asymmetric ether synthesis. Cannot be used for asymmetric ether synthesis. Cannot be used. No doubt, it cannot be used. What might be the reason? Can anyone? Why only symmetric ethers we can synthesize by using alcohol? Why we can't use synthesis of asymmetric ether the same method? Anyone? Think and tell me.
Because we took only one alcohol. Because we took only one alcohol. One type of alcohol.
Now, if you want asymmetric ethers, I will take different types of alcohol. One has ethanol and another one has isopropanol. I can take that one. What is that? If I want asymmetric ethers, I will go with different combination of alcohol. But that cannot be done here. What is the reason? But symmetric ethers, yes, efficiently this method can be utilized. Whether I am clear? So this is very important point. Cannot be used for the synthesis of asymmetric ethers. What might be the reason? Think and tell. Okay. So if I take asymmetric ether, say for example, I have taken C2H5OH and another one as CH3CHOH, CH3. Okay. So imagine we have taken two different alcohol. We have to take if I want to go for asymmetric ether. Now the problem here is I will have the mixture of product. Not one product, I will have the mixture of product. One will be C2H5O, C2H5. That will be one product. And another product will be C2H5O, CH3 and CH3. Right? So another one. Mixture. Same way, isopropanol can interact. But I will come to the point. So isopropanol can interact. Okay, so this can be another one. So what I mean to tell you is this will be the product, this will be the product, right? So that is one thing. When it comes to tertiary or secondary, even they can go for dehydration, where they will form the respective alkenes. Even that can be another product, especially if I take tertiary alcohol. Here I have taken secondary. If I take tertiary alcohol, so that's where I am going to have the result. That means I am getting hell lots of product. How I have to take out my interested alcohol? I have to go for purification. It is a headache, right? I am getting mixture of alcohol along with I am getting alkenes also. Unwanted products are getting formed. If I take tertiary, here I have taken secondary, right? So if I take tertiary, they will not go for ether formation only. Maximum one they will go for alkenes. Fine? So that's where we have the problem with this type of asymmetric ethers. So therefore, they will prefer from alcohol only for symmetric ethers. They will not go for asymmetric ethers because we will be having lots and lots of contaminants. And especially if I go with tertiary alcohol and all, definitely it will go for formation of respective alkenes. If you recollect, copper powder at 573 Kelvin, what was happening to tertiary alcohol? It was getting converted into alkenes. If you recollect, that's where there is a problem with this method. For symmetric ether, it's a very good method, no doubt. Fine? Any doubt? Now, whatever I will be discussing now, it is very, very important. Even another week, very, very, very important. Because of the disadvantage of method 1. Therefore, this reaction is gaining importance. Sir, please use dark one. Okay. Okay, Sukrut, I will see. Okay, I will make font size also a bit large. Fine. Sukrut. Okay, na? So that's where we have the next one. Very, very important concept. That is Williamson ether synthesis. This is a very important reaction, right? Rimer-Tiemann, coal base. This is also very important. Many times they have asked. Increased video quality. We can do that one?
They have to do.
Okay. Here it is already with maximum, it seems. If possible, in your mobile, if it is there, you can do that one. But whether now whatever I have written, can you see that one? It's visible. Don't worry, I will increase the font size. Now it's visible. Okay, this is also light, I think, not visible. No? It is 480p only, something that pixel. 1 minute. I am poor in all these things. Sir, white race is imitating. White race means?
Yeah, I don't know.
Whether we can increase the pixel? Oh, I'm not telling. Now, can you open that door at least? And marker, I think we require new one. Now I think it's visible, right? Okay. No, sir, it is visible. Okay, done. So we have closed the door and all. Fine. Now I think it should be visible. So shall I start with the class? Now I think it should be visible. Don't worry. Even I will increase the font size. Okay? So now we are coming to Williamson's ether synthesis. Very important reaction. Okay? So now when it comes to Williamson's ether synthesis, that's where we are going to use alkyl halide. That's where we are going to use alkyl halide. Okay? So that's where we have the alkyl halide. Now it will be treated with sodium alkoxide. It will be treated with sodium alkoxide. So that's where I have the sodium alkoxide. Right? So what do you mean by sodium alkoxide? That means where there will be interaction between positive and sodium and negative oxygen. So there will be sodium alkoxide. Now this will be resulted into the product. This will give rise to the product. All of us will know delta positive, delta negative, and here it is positive. They will come together. That's where there will be formation of respective sodium halides. Fine. Now this is delta positive, so this is negative. It will come with the positive. That's where there will be formation of ROR. That's where there will be formation of ROR. That's where we have the reaction. Fine. So this is the basic reaction for Williamson's ether synthesis, general equation. So what they are using? They are using alkyl halides and they are using sodium alkoxide, and both of them they will lead to the formation of respective ether. And please remember, Williamson's ether synthesis can be used for even synthesis of asymmetric ethers. That's where it is having advantage over other method, another method, that is from alcohol. It is having the advantage. Even in this we can go with the synthesis of asymmetric ether. That's where it is advantageous compared to earlier one. So whether I am clear, all of you have understood this one? Very important reaction it is. Williamson ether synthesis. Fine. So next, when it comes to this reaction, for example, only one limitation in this reaction here is I should not use tertiary halides. I should not use tertiary halides. Only limitation with this method here is I should not use tertiary halides. Now what will happen when if I use tertiary halides? Now I have CH3, CH3, CH3 and halogen. It can be chlorine, bromine, whatever it is. So I have a tertiary halide. Right? So tertiary butyl halide. I am going with general equation. Okay? Now it will be treated with sodium methoxide. It will be treated with sodium methoxide. It will be treated with sodium methoxide. Now, the product, one of the product naturally it should be sodium halide. One of the product here should be sodium halide. If I taken tertiary butyl bromide, then it will be sodium bromide. If I taken tertiary butyl chloride, then it will be sodium chloride, right? So that's where one of the common product is sodium halide. Now, another product will be CH3, C, double bond CH2, CH3. So that's where we have not got the reaction. We have not got the required product. We have got alkene. We have got the alkene. That's where we have 2-methyl propene. We have got 2-methyl propene. Right? So that is the problem. Now what should be the another product? What should be the another product? Now I think it's visible, right? Yeah, in between it's getting blur. Yes, they were right. Now it's coming. So now it became blur. Oh, it's maybe due to poor network, no? Now it's fine. Okay, now? So that's where we have the reaction. What should be another product? Another product I have not written. What can be another product? It will be methanol. Another product will be methanol, CH3OH. Because one of the hydrogen has been donated H plus to the alkoxide. So that's where we are getting methanol. but still it is becoming blur, and then once again it's coming back. Now it's fine. All of you can see the board, right? So that's where we have the methanol. Okay? Any doubts? So therefore tertiary butyl halide we cannot use, or tertiary halides one should not use. We have to go for primary halides only. Alkoxide, yes, we can go with any of the alkoxide, but we cannot go with the tertiary halides. Fine? Because it will give rise to alkenes. It will give rise to formation of alkenes. Fine? Any doubts? Okay, anyway, I will stop here. Okay, I think even network some problem is there. I will stop here, don't worry. So tomorrow I will go with further detail about Williamson ether synthesis. Fine? Thank you. Don't worry. We will use new pen tomorrow. Okay, na? And I think today major problem is something about network. I think that was the major this one. I can see in between it is becoming sometimes blur and it is becoming normal. Okay? So no need to worry. Fine. Thank you. Thank you. Take care. Bye.